Alright guys, so one of you asked me the question how to use universal gates, right? So yeah, that's one very important fact that I missed when I was doing my video earlier. So thank you so much for bringing that up. Now I'll be teaching you guys how to use NAND and NO to actually answer questions in the papers, right? So something that we can see in quite a few logic gate questions is that they ask us to actually show how to use NAND or NO gates to uh, show whatever boolean expression that we got, right? So in the earlier question, what we did was we drew the logic circuit using and OR gates, right? So in the questions, sometimes they specifically ask you to use NAND gates, or they ask you to specifically use NOR gates to actually show the desired output, right? So this is how you can actually do this in a very easy and reliable manner, right? So there's just three things that there's six things actually that you have to remember, right? So these are them. Okay, so you need to learn how to show AND by using NAND. You have to learn how to use NO to show and likewise for O and NOT you have to learn how to use NAND and NO, right? So this is how you show the AND gate by using NAND gates. Okay, simple as that. Okay, so when it comes through here it will be AB bar, right? So when it goes through this again, so the other thing is the NOT gate, right? That's one of the most important things when it comes to this. It's anything you send it through the same thing, right? So if it's A, when you send it through NAND by itself, it turns into A bar, right? So when it comes to NO, if you take A and send it through itself using a NO gate, it will turn into A bar, right? So like that you get this, and then you send it through the same thing again, it will be A B double bar, right? So the bars will cancel each other, which will give you AB, right? Likewise for the NO gate, when it comes to the O1, right? So notice this, right? If it's AND, if it's AND that you want and you're using NAND, you just have to send it through the same gate twice, right? If it's O that you want and you're using NO, you just have to do the same thing. You have to send it through the same gate twice. Right? See, if you're using NAND to get AND, you send it through the same gate twice. If you're using NO to get O, you send it through the same gate twice, right? But if you're using NAND to make O, there's a different manner that you have to do. Okay, so this is how it happens. So when you go through this, it becomes A bar, right? When it goes through this, it becomes B bar, right? So that's A bar because of this dot B bar, right? So because of this part, it becomes like that, right? So when you remove this big bar, it becomes A bar bar plus B bar bar, and like before, the double bars cancel each other and then it results in A plus B. Okay, so it's the same way that you have to draw for and using no, right? So it's like this: A, B. Right, so this is how it happens. This becomes A bar, this becomes B bar, right? So it's A bar and B bar. When you send it through this, it becomes there. Okay, so when you remove the big bar, it becomes A bar dot A double bar dot B double bar, which means A B, right? So it's very simple as to how to convert these things, right? So it's just you have to remember this and this pattern, right? So if you send something through itself using a universal gate, it turns into the inverse, right? It's the NOT gate, right? But in the case that you want to use a certain gate, a certain universal gate to take the same thing, you know, like the same thing in the sense that if you're using NAND to create AND, you send it through the same thing twice. If you're using NO to create O, you're sending it through the same thing twice. But if you're taking NO and you want to make AND, you send the all the variables separately through the gate and then you combine them, right? See, you send it separately through the gate and then you combine it with another gate. The same thing here. If you're using NAND to make O, you send the different variables, the different inputs through the gates separately and then you combine them, right? So yeah, that's how you actually make these gates, right? So now I'll show you guys how to use these things and how to simplify these things and create the desired circuit. Okay, so now we will be doing these two very simple exercises, right? We'll be drawing A into B plus C using NO, and then we'll be drawing A into B plus C using NAND, right? Okay, so you just have to remember these things, right? You use these things and directly draw this first. Okay, so A, B and C. So we need to create B plus C, right? So we will be, since we're using NO to create B plus C, we will be using this method, right? So we're going to directly draw that. Right, we have that, right? And then we have to get A, right? So there we have A. Now what we have to do is we have to put a AND gate between the two things that we got, right? So this is A we have over here and this is B plus C we have over there. We have to put an AND gate between these two, right? So what we're going to do is we're going to get this, right? So we send them separately through the gate and then we combine them, right? So we do that, and then we combine them, right? So now here we have A into B plus C, right? But you have to simplify this. See, there's a lot of repetitive gates, right? The same thing, right? So how you simplify this is that if the same wire goes through the same gate twice in a row, you can cut them off, right? Like the same thing, like since this is like a bar, right? This is a NOT gate. NOT is just the same wire, right? Without using the gate, right? So what I mean is, so just imagine that this wire, imagine, okay, this is a hypothetical situation where this wire, let's say this wire, okay, there's that wire, okay, that is A, right? So if you add a NOT gate to this, right, that's a wire and that is A, right, that is the output, okay. You add a NOT gate, right, then it becomes A bar, and then you add another NOT gate, right, and then it becomes A bar bar, right. So you can cut off the two bars and just say A, right. So that means if there's two gates of the same kind repeating in the same wire, right, you can just cut them off, right. See, the same wire, two gates repeating, so you can cut them off. But if there was another gate here, you can't cut it off with this because there's two wires connecting over here, right. You can't cut off a combination one, right. Only the wires that only the gates that take the same wire can be cut off, right. So you cut those two off and then you get the final answer as A, B, C. See, we got this over here, we got this over here, we got this over here, and we cut these two off, and this is the final answer. Now we will be drawing the same gate with NAND, right? Okay, so in the same method, we're going to do it, right? Right, so we need to just take A, right? We need B plus C, right? So to create B plus C using NAND plus, right? So this is the thing that we have to draw. So right, and then we need to connect them, which means we have to draw this, right? All right, so now here you can see that you can't cut off anything, right? See, this comes in one wire and there's no repetition. This is one wire, no repetition. They get combined, so we can't cut this off with either of these, right? And they get combined here, and because there's a combination here, we can't cut it off with this because this runs through a single wire, this does not, right? So we can't cut off anything. This is itself is the final answer. In universal gates, there's this way of asking the question that results in the student being really scared and confused. So most of the time when they see this, people skip the question because they've never seen it before, right? But if you look at the 2016 question paper and all, you can see this very clearly, and it looks confusing but it's very easy, right? So I'll teach you that. So it's this thing right here, right? So they give you a chipset. So because here's the thing, this is what the actual circuits you can buy look like, right? They don't come separately as separate gates, they come in a chip like this, and the chip includes a lot of gates, universal gates, right? So when you're using these things to make circuits, you'll have to use a chip like this, right? So basically what they're asking you to do in questions is to put this circuit into this chip, right? So there's two ways that you can actually do this, right? So basically you have to draw the same thing using this, right? So you can just draw it on this, or you can use the numbers, right? Always keep in mind that the number 1 starts from the side with the little curved part, right? And it goes like this, and then over here, and then ends up over here, right? So there was an MCQ question where they gave different diagrams and asked which one was correct. So in that case, you have to remember that the curved part is where the number 1 is always situated, right? And it goes like this, and then doesn't go like this, it goes like that, right? Okay, so we'll first draw this, right? So using this you have to draw this, right? So A goes into, no, we'll start from over here, right? B will go from one circuit, one gate, right? So just draw B right there, and then you take 2 wires from it and you connect it into these 2 things, right? There you go. B is connected into one gate, and the output of it is taken and fixed to another, right? Similarly, C is taken and fixed to the same gate, right? So we'll take C as this one, right? C, and then you put it into one gate, right? And then you take the output of this, put it into one more gate, and put this output also into the same gate, right? So see, B goes through one gate, C goes through one gate, those 2 go through another gate, right? And then there's A, right? So we'll put A somewhere over here, right? No, we'll put A over here. Okay, so A has to go into a gate with the output of this, right? So the output of this is this. So you take it, right? And then you bring it around, use a ruler, okay? Then you connect it into another gate, and with it A has to connect, so there it goes, right? And then those 2 connect, the output of it goes through another gate, right? So it has to double, right? So you just take that wire, break it into 2 parts, take one and fix it over here in one slot, and the other one you fix it in the other one, right? And then here we have the output, right? So you take that, you just take it as one wire, and then you put it as F, which was the output, right? And then, or you could write output, right? So there you have it. So if you're told to use the circuit board, if you're given a diagram and if you're supposed to draw it, if they tell you to draw it and use it, this is how you have to do it, right? Or there's also another method which I would not recommend, right? If you're running out of time, if you're really running out of time and you don't have a lot of time to get this done, then I guess it'll be okay to do it this way, the way that I'm going to show it right now. But I advise you, please try to stick to this method or this, right? Because I'm not quite sure whether they'd give marks for this, right? Some teachers do, some teachers don't, right? So this is that risky fast method, right? So you can just write down you can write it down in point form, right? You can write it like connect B to 1 and 2, connect C to 7 and 8, connect 3 to 4, connect 9 to 5, right? Likewise, you take connect 6 to 19, connect A to 18, connect 17 to 16 and 15, and take 14 as the output. Like that, you can write it down as well. There's nothing wrong with doing this, but there are some teachers that do not give marks for this. So I hope that was helpful for you all, and thank you again for raising the question and reminding me that universal gates are very important. So go through it, and if there are any more questions, please let me know. Always happy to help. Thank you.